Hello everyone, in this video we'll be going to discuss about the rational number, and before starting the rational number we'll go through some important facts. We'll try to recall number family with examples and number line, and at the end of session we'll try to solve some questions. Let's start. Do you know that which number system is oldest in the world? That is Babylonian numbers, and this is 5000 years old. Can you imagine? Now here we have Babylonian numbers, Egyptian numbers and Roman numbers. Then you will find something in a common. What's that? Here we have to keep repeating the patterns as we required. Also, we have new symbols for each new magnitude. Now it's really difficult to remember all the symbols and to express a big number in these forms. So we need a new number system which should be more convenient. Early humans likely to count animals in a flock, members in a tribe using tally marks or body parts. As the complexity of life increases and things to count also increases, then these number systems are not sufficient. We need a new number system which should be more convenient and easy to understand. Now here we have Devanagari numbers and Hindu Arabic. You will find that in these two systems we have fixed number of symbols. We can assign them different values according to their position, which is called as positional notation. Let's take example. If I have here 725. Now this value of 2 is 20 according to its position. Similarly, the value of 7 is 700. So with the help of these 10 symbols, we can write any imaginable numbers. That's why we prefer the new number system over the older one. But do you think that we are not using any older number system nowadays? So nowadays also we are using Roman numbers, and this Babylonian numbers also we are using. So the base of Babylonian number is 60. So the concept of Babylonian number we use when we have to measure time, when we have to measure angles. Now let's go back to the kindergarten days and try to recall number family. You might have heard one rhyme of kindergarten days, that is 1, 2, 3, 4, 5, once I caught a fish alive. So suppose if I am visiting a garden and I saw there are so many different types of plants. Now if I want to count them, then I need to start from 1, right? 1, 2, 3, 4, 5 and so on. So that's why the natural number which start from 1 is also called as the counting numbers. Now natural number is denoted with capital letter N. Now here we have a number line. Suppose if we have to plot 7 on the number line, then what we will do is we'll just draw this number line and then we have to just mark this 7 and that's it. We are done. Now suppose if I have a box and in that box I have 5 chocolates, and if I just take out all of them, how many chocolates are there? There is nothing. But we don't have any number in the natural number to denote nothing, right? So that's why we have whole number. There we have 0. 0 means nothing. So natural number with 0, and that group is called as the whole number group, that is denoted with capital letter W. Now 0 is the smallest whole number, or we can say that in whole numbers 0 doesn't have any predecessor. But do you think that there is no number in the left of the 0, or there is no number exist less than 0? Yes, we have. That is integers. That we'll be going to discuss in the integers. Now integers include all the natural numbers, 0 and negative of natural numbers. Now why 0 is specified separately? Because 0 is neither positive nor negative. We cannot classify 0 as any of them. If you'll see, then here we have all the natural and here we have negative of natural. Now in the left of the 0 we have all the negative numbers. So left side we have all the negative numbers. And in the right side of the 0, we have all the positive numbers. Now, as we will be moving towards the right side of the 0, we will be getting new and bigger positive numbers. Now, this 0 can be considered as midpoint of number line. Now, here we have some facts about the integers. So, -1 is biggest negative number or negative integer. Similarly, +1 is smallest positive integer. Now, do you know that how we can compare integers with the help of number line? Let's take example. Suppose if I have to compare -3 and -1. Now, the first method is we have to check that which number is in the right side of the other one. The number which is in the right side will be the greater than the other one. So, here we can see that -1 is in the right side of the -3. So, definitely -1 will be the greater integer. So, we have one more method that we can apply for all the negative numbers. So, the negative number which is closer to the 0 will be the greater negative numbers. So, let's discuss some important statements. Now, are all natural numbers are integers? So, in the group of integers that is denoted with capital I or Z. So, we have here negative infinity, -3, -2, -1, 0, 1, 2, 3 and up to positive infinity. Now, natural number. Do we have natural number group in the integers? Yes, we do. That start from 1. So, it will be yes. Yes, all natural numbers are integers. Next we have, are all whole numbers are integers? Definitely yes, because there is 0 also in the group of integers. So, it will be again yes. Now, do you think that is there any number between any two consecutive integers? For example, here we have 0 and here we have 1. Do we have any number in between these two? Try to think. Yes, we have, and actually we use them a lot in our daily life, such as 1/2, 1/3, 1/4 or 2/3. What type of number is this? These are called as the fractions. In the next slide, we'll be going to discuss about the fractions. A number which can be expressed in the form of p by q, where p and q are the whole numbers and q is not equal to 0, that is called as the fractions. Now, let's take an example and it will be very easier to understand fractions with the help of that example. If I have a circle and if I divide that circle into 3 equal parts, and I'm just going to shed one of the part. Now, what fraction of part or what fraction of the circle is shedded? So, that is 1/3. So, this is the example of fraction. Now, we can have some more examples, that is 2/1, 2 and 1/4, 5/7. So, all these are the examples of fractions. Next, we have an animation. Let's discuss this. So, here we have a submarine and here we have a cliff. Now, it can be considered as mountain also. Now, the height of the cliff is 750 meters. So, this height we can represent in the form of kilometers, and we know that to convert meters to kilometers we need to divide by 1000. So, that is 3/4 kilometers. Now, the position of submarine which is below the sea water level, and we have already studied in the lower grades that if something is below the sea water level, we have to denote with negative sign. Now, this -750, if we convert to the kilometers, so we have -3/4. Now, what type of number is this? we know that fractions cannot be negative. So this is rational number. Now it looks like a fractions, but it's not a fractions because it's negative. So that we'll be going to discuss in detail in next slides. Now the definition of a rational number is a number which can be expressed in the form of p by q, where p and q are the integers and q is not equals to 0. Now try to recall similar definition we had for the fractions, and in that here we had that p and q can be any whole number and q is not equals to 0. That is the same restriction we have for the fraction also. Now let's take example. So here we have 2 over 3, negative 7 over 9, negative 3, 0 and 1. Now look at the examples. If you'll observe, then this is a kind of a fraction. And this is example of integer or negative integer. And this is 0, so it's kind of a whole number or example of whole number, and 1 is example of natural number. So what we can conclude that all integers, fractions are rational numbers. So we can say that all fractions are rational number, whereas all rational numbers are not fractions. Now what is the main difference between them? That is, fractions will be always positive. Fractions cannot be negative, whereas a rational number can be positive and it can be negative also. Now let's see, here we have a question. Let's try to solve this. Which of the following is a rational number but not a fraction? Now try to recall the definition of both. So 3 by 5 and 8 by negative 7, 3 by 14 and 25 by 50. So in case of rational number, p and q can be integers, and in case of fractions it should be a whole number. Now the denominator is negative, so it's not a whole number. It means this is only rational but it's not a fractions. So the correct answer for this question is option 2. Now let's see what we have discussed so far. So we discussed natural number, whole number, integers, and then we discussed about the rational number. Now let's try to recall what are the symbols that we used for each of them. So rational number is denoted with q, integers with I or z, whole number with w, and natural number with n. Now we'll discuss positive rational number and negative rational number. Now for positive rational number, if both of them will be positive and positive, say p and q are the positive, so it will result positive rational number. Or if both of them will be negative also, then we can cancel the negative and negative sign. Let's see the example. So here we have 5 over 11. 5 over 11 is positive, so overall result is positive, and here we can cancel this negative and negative. Now we have 3 over 4, which is positive rational number. For negative rational number, the condition is one of them will be negative and the other will be positive. So at a time, say q is negative and p is positive, and in the second condition p is negative and q is positive. Let's see some examples. Now here we have, so the denominator is negative, and in negative 3 over 4 here we have numerator as negative. Now it's time to discuss about equivalent rational number, lowest form of rational number, and standard form of rational number. First let's understand equivalent rational number. Now equivalent means, by the name itself we can understand that equal rational number. Let's directly go to the examples, it will help you to understand in better way. Now if you'll observe the examples, so here we have 2 over 4, 3 over 6, 4 over 8. Now is there any pattern, or can we simplify all of them? Yes. If you simplify 2 over 4, you will get 1 over 2. Similarly 3 over 6 and 4 over 8, all of them will result 1 over 2. Now what we observe that the rational numbers seems to be different, but their value is same, or when we simplify to the lowest form, they are actually the same. Let's go to the definition. The rational number do not have a unique representation in form of p by q. They do not have unique representation. What it means, when you simplify, all of them will result the same. So that is known as the equivalent rational number. Now if we have to write equivalent rational number for any rational number, so let's take a question. So for 2 over 3, if I have to write 3 equivalent rational number, so what I'll do, we can multiply this rational number with 2 over 2. So we'll get 4 over 6. Again, then we can multiply this rational number with 3 over 3. We'll get 6 over 9. And then we can multiply the rational number with 4 over 4. So we'll get 8 over 12. So 4 over 6, 6 over 9 and 8 over 12, all of them are the equivalent rational number to 2 over 3. At the place of 2 over 2, 3 over 3 and 4 over 4, you can use other numbers also. Now let's discuss what is meant by the lowest form of rational number. So if the numerator and denominator, they do not have any other common factor than 1, that is called as the lowest form. For example, 5, 4, 7. You will see that 5 and 7, they do not have anything common other than 1. So we can say that 5, 4, 7 is in the lowest form. Now if I write here 6 over 12, but 6 and 12, they have something in a common. What is that? That is 6. So we need to simplify this and we'll get 1 over 2. It means this 1 over 2 is the lowest form. Or in other words, what we can say that A and B must be relatively prime. Or relatively prime means co-prime. Now what is meant by the co-prime? If two numbers, they do not have anything common other than 1, is called as the co-prime. Any two continuous number is co-prime. For example, 14, 15 is co-prime, 15, 16 is co-prime. See, it is not compulsory that the co-prime must be prime numbers. They can be composite. Here you will see that 15 and 16 together, they are co-prime, and 15 is composite number and 16 is also composite number. Let's see how to convert rational number to the lowest form. So we need to divide the numerator and denominator by their HCF. Here we have an example. So 28 over 54. So the HCF of 28 and 54 is 2. So we'll be dividing by 2 by 2. So what do we have? We have 14 over 27. Similarly, we have another example. So 16 over negative 40. So what is the HCF of 16 and negative 40? So that is 8. So we'll be dividing by 8 and we have here 2 over negative 5. Now remember, while solving for the lowest form, the denominator can be negative. Okay. Now let's discuss standard form of rational number. So here we have two conditions. The first is that common factor between numerator and denominator should be 1. This is the same condition as the lowest form of the rational number. So we can say that our standard rational number is also in the lowest form. Now we have one more condition for the standard rational number, that is denominator is always positive. So in the previous example, we saw that the denominator was negative. It means that was not in the standard form. Let's take some example of standard form of rational number, that is 2 over 3, negative 5 over 2, right? So the denominator should be always positive. Now let's see what to do when we have negative denominator. So we need to divide the numerator and denominator by their negative of HCF. So here we have example. So both are the positive, so we do not have to worry about that. We can simplify by dividing by the HCF and HCF. We'll get 14 over 27. In the second example, here we have negative denominator. It means we will be dividing by their negative HCF. So divide by negative 8, divide by negative 8. Now what do we have? We have negative 2 over 5. So that's the standard form of rational number. Now let's try to solve one question. So convert the following rational number in the lowest form. So that is negative 12 over 30. So negative 12 over 30, and the denominator is positive. So we need to just divide by HCF and HCF. So what is the HCF of 12 and 30? That is 6. So we'll be dividing by 6 and we'll got negative 2 over 5. So the correct answer for this question is negative 2 by 5. Now let's try to solve one more question. So here we have a question which says that we have to check whether this number is in the standard form or not. If it is not, then we'll be converting into the standard form. Now we'll quickly check the two conditions for the standard rational number. That is, the number must be into the lowest form, but it's not. And also the denominator is also not positive. Now I'll just quickly write down the number. So negative 28 over negative 210. Now we know that if P and Q both are the negative, so we can cancel the negative and negative sign. So cancel and cancel, we are left with 28 over 210. Now we just need to convert into the lowest form. So I'll be dividing with the HCF of both numerator and denominator, that is 14. And when you will divide by 14, you will get 2 by 15. So the correct answer for this question is 2 by 15. Now let's discuss one note here. So if we have A, B, C, D such that they are the positive integers and A over B is less than C over D, if and only if AD is less than BC. So to understand this, we'll take this example. So we have 4 over 5 and 7 over 8. So we have to do the cross multiplication. So what I have here, 4 times 8, and here we have 7 times 5. So we'll get 32 and 35. So we know that 35 is greater. So the side with greater number will have greater rational number. So 7 by 8 is greater than 4 by 5. So what we have discussed so far in this video, so we discussed classification of numbers, rational numbers, positive and negative rational number, equivalent rational number, lowest form of rational number and standard form of rational numbers. Thank you.